welcome to the video about solving systems of equations by graphing. We're actually going to start out with the problem that we ended the previous video on, the matrix equations. And so this should look familiar. And remember, we made a matrix by going 3, 2, 9, 6, taking the coefficients there. This was x, y, and this was 6 and negative 6. And if you remember, we got the error message. And so we said that these actually are parallel lines, and so that there was no solution. So L-U, wow. Let's try that again. S-O-L-U-T-I-O-N, no solution. Okay, so we want to look at this situation more closely, and we're going to look at it more closely by graphing it. So I'm going to go to the next slide here, and what I want to do, these are in standard form, and I'm going to show you how to graph from standard form in a minute, but let's convert them to y equals form. Okay, that's the y equals mx plus b form that we're familiar with, for graphing. So I'll take this first one over here. If we have 3x plus 2y is equal to 6, I want to get the y by itself. So I'm going to subtract 3x from both sides. Cancels there. I have 2y is equal to negative 3x plus 6. Just wrote those next to each other. Divide everything by 2. Y is equal to negative 3 over 2x, because 3 over 2, right? And then 6 divided by 2 would be plus 3. So my first equation is y equals negative 3 over 2x plus 3. I'll use a different color for the second equation. We have 9x plus 6y is equal to negative 6. Subtract 9x from both sides. 6y is equal to negative 9x minus 6. Divide everything by 6, so that the y equals negative 9 divided by 6. We'll simplify that in a minute. Negative 6 divided by 6 is negative 1. Well, 9, 6, 3 goes into both of those evenly, so that's going to be negative 3 halves x minus 1. Negative 3 halves x minus 1. So hopefully you're saying, oh, looky, looky, right? They both have a slope, the same slope of negative 3 halves. So that when you graphed these, which we'll look at on the next page, their lines are going to be parallel. So if you look at the next page, here was the first one, y equals negative 3 halves x plus 3. Starting at 3, going down 3 and over 2, there's my second point, drew in my line. Excuse me. This one was y equals negative 3 halves x minus 1. Start at negative 1. Go down 3 and over 2, there's my second point, draw my line. So clearly we have parallel lines. And because we have parallel lines, as we said many times, there is then no solution. Okay, let's look at another example. Y equals 3x minus 4. This is already in slope-intercept form for us, so that's nice. So we start at negative 4, and we're going to go up 3, 1, 2, 3, and over 1. And up 3, 1, 2, 3, and over 1. Notice how the scale is by 2, so we have to be careful with that. And I'm just going to draw on this line. That's kind of off. Let's try again. That's better. And then this equation, we're going to start at positive 1. And go up 1 over 2 for my slope. Up 1 over 2. So again, grab a line. And so hopefully you're saying right away, oh look, there's an intersection here of 2, 2. And so the intersection point is 2, 2. And we can check the solution by plugging it in. So if the solution is 2, 2, this is my x and this is my y. So if we use the first equation, is 2 equal to 3 times 2 minus 4? Well, 2 is equal to 6 minus 4. 2 is equal to 2. So it works for the first equation. If we take the second equation, is 2 equal to 1/2 of 2 plus 1? Well, half of 2 is 1 plus 1, and clearly 1 plus 1 is 2. So we've checked that this solution, 2, 2, works for both equations. Okay. Another quick one we can do, if we do start at 5, 1, 2, 3, 4, 5, and we're going to go up 3, 1, 2, 3, and over 1, and draw that line in. And then this one starts at 10, and goes down 2 and over 1, down 2 and over 1, and draw that line in. Then clearly we can see again that the intersection point is 1, 8. So we need to check the solution, 1, 8. So if 8 goes in for y, remember this is x and this is y, is 8 equal to 3 times 1 plus 5? Well, yes, 8 is equal to 3 plus 5. 8 is equal to 8, so that one checks out. And we can plug in 8 for the second equation, -2, plug in the 1 for the x, plus 10. 8 is equal to -2 plus 10 because 8 is equal to 8, and that also works. So another nice solution to 2 lines, 2 equations. All right, now we have a trickier situation because we have 2 equations that are both in standard form. So one thing you can do, like I showed you on the very first example with the matrix equation, is you can convert each of these to y equals 4. But a more efficient method is to try and use the intercepts to get 2 points and then draw a line between the 2 points. The x-intercept will be along the x-axis, and that's going to be when y is 0. So if y is 0, 2 times 0 is just 0. So we can cover that whole thing up and see that we just have 3x is equal to 12, or if I divide by 3, x is equal to 4. So I have an x-intercept of 4, 0. And if I want to find the y-intercept, that's along the y-axis. So that's when x is equal to 0. So I just covered up the x because 3 times that 0 is just 0. So I have 2y is equal to 12 divided by 2 divided by 2. Y is equal to 6. So I have an intersection point there, an intercept, of 0, 6. So if I plot these points, 4, 0, and 0, 6, again, I have 2 points. Draw a line. Extend that a little bit. Let's do the second equation. Find the x-intercept, so we cover up the y. So we have 5x is equal to 20, divide by 5, divide by 5, x is equal to 4, so I have an x-intercept of 4, 0. Find the y-intercept, so cover up the x. 2y is equal to 20 divided by 2, divided by 2, y is equal to 10. So I have a y-intercept of 0, 10, because the x was 0, the y was 10. So that probably is going to be our intersection point there, because 0, 10 is up here. Find a line. So I have an intersection point of 4, 0. Okay? And again, I can check my answers. I might want to just do it sort of verbally, or I can do it, well, let's do it. Check 4, comma 0. So is 3 times 4 plus 2 times 0 equal to 12? Well, you can just see that. 3 times 4, yeah, that's going to work. If we check the other one, is 5 times 4 plus 2 times 0 equal to 20? Yeah, because 5 times 4 is 20, so that works. Here we have a situation where we have one equation in y equals form and one equation in standard form. So let's do the y equals form first, because that's what we're most familiar with. This says y equals negative 1/3 x plus 4. So I'm starting at 4, and it's negative 1/3, so I'm going down 1 and over 1, 2, 3. Down 1, 1, 2, 3. So I will draw a line in. This one, I'm going to do the covering up bit. Okay, I don't have my little square, but I can just picture covering up the y so that I have 3x is equal to 24, divided by 3, x is equal to 8, so I have an x-intercept of 8, 0. If I cover up the x, I have 3y is equal to 24, divided by 3, y is equal to 8 as well, so I have 0, 8 as that y-intercept. So 8, 0, and 0, 8, and let's get a line between those. And hopefully we're seeing a nice intersection point here of 6, 2. And we do want to check our solution. So we can do, is 3 times 6 plus 3 times 2 equal to 24? Well, 3 times 6 is 18. 3 times 2 is 6. That's equal to 24. So that one worked. And the other equation is 2, my y equal to negative 1/3 times 6 plus 4. Well, a third of 6 is 2, and it's a negative 1/3, so it's negative 2 plus 4. Negative 2 plus 4 is 2, so that one works as well. Beautiful. That concludes the video. You might want to take a moment to put some of these graphing problems on your gold summary sheet.